floating up in the shape where it's floating out.
So after our kinetic modeling and finding our expected distances, we figured, yes, like we can actually, with this trebuchet, out-engineer what the majority of our competition would be bringing to the actual Punkin Chunkin event. So next, we moved on to static modeling in SolidWorks and to construction, which Alex will explain.
So we knew that to win this, we would need a large trebuchet. We're talking 15 feet, 20 feet tall. But we're not going to jump from this to a 20-foot thing. There has to be some in between, which is why we decided to start building this model right here. Now this model's got about a 5-foot base height, and with the arm it's going to go to about 10 feet. And I'm here to talk to you about how the design process works. You'll see later, if you want to look on the first computer, we have the design and the way we went through it. And we basically used, what we found from this trebuchet right here is, as a byproduct of the acrylic, it's very floppy. We had to insert these wings over here to keep it up. It didn't work. So we needed something sturdier. So we decided, let's make it bigger. Let's use these giant beefy 2x4s. Everything is made to be strong in this. So you see you have these gussets which are holding everything together. You see them all over. There's 4 on the bottom, there's all over the sides. And these 2x4s which are pretty strong. And you see that we've designed this thing to be very stable. We don't want it shaky. Now typically you'll see trebuchets have wheels on the bottom so that they could roll around. But with our design, since the cart is up here, none of the energy gets transferred. So this is a very stable, non-moving object right here. And now, from the design, we started looking at the cart, because we found from this, the cart is the most important aspect. Because this is absolutely stable, all the motion is in the cart, all the launching is in the cart, that's the big point. That's what we have to design. So we looked and we decided what we're going to do is, we're going to take giant metal U-channels and put them along here and along here. And those are going to be our rails. You can totally see it there. These big metal rails. Now, we're going to order wheels from McMaster, we're going to get all that, and assemble this cart using steel and aluminum. Aluminum being lighter and therefore better for some purposes, steel being stronger and better for some purposes. And we're going to take this cart, and when you launch it, when you put it on, you'll be able to lift the weight. We're working on having a rope that'll go all the way up here, so that you can actually pull it up, take it past the point where it's centered, and then it'll drop by itself. So the cart will literally fly forward, shooting the arm and back too, as you saw over there. Now, we are going to have stops over here and over here so that the cart can't attack anyone because this thing is flying at a crazy velocity. Furthermore, above the wheel, there's going to be metal bars that are attached to these stops so that the cart can't bounce out. Because what we learned from this is that the cart is